All right, so yeah, so I've been working on this since about April, and it started as a crazy idea. So if we can just go to the next slide, Simon, if you don't mind. I roped Tom into this as well. So hopefully a lot of our community have heard of Kenney, and if you haven't, you're missing out on something because he does the most amazing free artwork for the game dev community, and it's really, it's just fantastic. It's high quality. Um, it's got everything you ever want to need. And one of the things he did earlier on this year was produce a bunch of starter kits for Godot. And this is an example of one of them. This is the his little Kenney 3D platformer starter kit. This was the first one he did, I think. And I came across this and I was looking at it. I was thinking, you know what? Can we go to the next slide now, Simon? Can we do this? Can we do that in MonoGame? That was where this all started. So I gave myself some goals. So it was like, can we use the exact same assets without any changes? Can we get it as close as possible to the original, or possibly even better? The slides have gone, Simon.
Sorry, I was just briefly putting up Kenney's website for reference.
Yeah,
Sure.
can we keep the third-party NuGets to a minimum? Because I didn't want to like rely on a third-party engine or anything else like that. I wanted to try and get this as close to what you can do with MonoGame as possible. And I think there was just like one NuGet that we've used. I wanted to use Blender somehow because I love Blender, and I wanted to keep it as simple as possible. So those are the constraints that we were under. Now, if we just do the next slide, this is where it started. So I managed to get all the assets in. There's no lighting, as you can see from that screen. And then there's no animation. So then we moved on to getting basic effect working. So if that's the next shot there, as you can see, that's basic effect working. It's okay, but it's nowhere near the original. And then I started looking at implementing like animation stuff. As you can see, the arms on the little dude there are in the wrong place. It's that was actually harder to figure out than I liked, because the particular animated character doesn't have a skeleton or armature. It's mesh-based animation. So, and there aren't any game samples for that. And then we moved on to like lighting and shadows and stuff. So that's the last one. And I think what we've come up with is a pretty good. I think is excellent. I roped Tom in like for the last month or so. I think, is it a month, Tom?
Yeah, I think so.
Yeah.
Sometime in the last couple of weeks. Yeah.
Yeah, so I roped Tom in for the last couple of months because we needed some help with shaders and getting stuff working. So if we go on to the next slide, I'm now going to show you guys this whole thing, this whole starter kit. So I'll go and share my screen. It won't let me share my screen.
You might have given permissions. This happened last time, Simon.
Right, I'm sharing, Simon. So we've paused the preview to share. Can everyone see my screen now?
Yes, I guess so. We see your Discord screen.
Yeah. Right, okay. So I'll tell you what, the first thing, what we'll do, we'll go to the project first and we'll just get it up and running so everyone can see it. So we've got this is a game code. We'll just run it up first. Yes, I'm on a Mac. I apologize.
Oh, the real challenge.
I haven't pulled any changes down, Tom, so if you've done anything this morning, it's not going to work. So the first thing I'm going to do is mute the music. I love the music, Tom, but it's just a little bit too much. So as you can see, got 3D camera. Okay, got a little dude. He can run around on the stuff and pick up things. and go on a little bouncy jump pad. That's something that's new that we added, and I can completely miss stuff.
It wouldn't be a proper demo without a fail.
Yeah, so I just want to get to the next level because there's something even funnier on that one. So we've got, running around, jumping. We can pick up things. So there's collision detection, everything in here. There's a trigger point to detect when we finish the level. There's 3 levels in here at the moment. So we've got another one here that we built, and I'll show you how I went around building these in a second. So there's clouds, all this kind of stuff, and then we've got another jump pad here. This is going to be funny because Tom's not seen this, I don't think. No.
Expert launch.
Yeah, I don't know if any of I think it's just myself and Tom that's been playing with this. I don't know if anybody else on the team has actually seen this.
I've not had a chance. This is the first I'm seeing most of these. I love it. You got an effect of a SpaceX launch there.
Yeah.
Time seeing it looks great.
And then this is the last level, which is not finished yet. So we got moving platform, which is something I added, I think, last night or the day before. But as you can see, it's a fully functioning 3D game. So how do we go about building that?
Yeah, I mean, I think it's fantastic that Kenney does these kind of things.
Yeah.
He gives us permission to even do this because he's a big fan of game development communities and getting things out there. So that we're expanding this now and hopefully more of Kenney's stuff, I think, in the future, maybe.
Yeah, I mean, I will admit, I did reach out to Kenney before I started this and said, are you okay with us doing this and promoting the fact that we've done it with your stuff? And yeah, he's like, yeah, fine, go for it. Which is good. So all the code is here. We're not going to ignore platforms. Everything's in like the source code, more or less. So we've got a whole bunch of classes that you'd expect from a 3D game. We've got a camera class, which is like the third person camera. We've got some animation stuff that we need to keep the keyframes from the animation. There's a collision mesh and convex hull things for doing all the collision detection. I don't want to spend too much on this. If the community, what we can do is we can probably do a deep dive in some of this a little bit later on. The whole thing is based off a base entity class, which has some very basic stuff to do with collision detection and models and rendering bits and pieces. We've got a JSON file loader, which I'll talk about. So all the levels are in JSON. And I use Blender to create the levels and export the data. So I'll show you that in a moment, how that all works. So that's this sucker here. We've got a shadow processor. This is like a standalone class that we wrote that has the shadow system in this demo is not as complex as the one in the Ascent demo. The Ascent one is quite an advanced shadow system. In here, this is just literally shadow mapping, very bog standard shadow mapping, but it suits this kind of game. And if you want to just get started, that's a good place to start. So that comes out of the box. We've got a post processor that does bloom and a vignette as well, which you may well have seen. And then we've just got these. This is the code for doing all this stuff. So we've got like a coin. We've got collision systems. It does some animation, making it bob up and down, stuff like that. We've got the moving platform, which I did just a little while ago, last night. The jump pad, the goal. This is literally just an empty that has a bounding sphere, and you detect the collision, and then you move on to the next level and stuff like that. So this is all in here. We've got one platform at the moment, which is desktop GL. That's just referencing the code. we've got the content pipeline system. This is where we had that one NuGet that we were using, which was this NuGet package to build convex hulls from the meshes. So we didn't have to define those ourselves. That was something that Tom added. I don't know if you want to talk about that for a moment, Tom, or shall I just keep going?
Sure. I mean, we wanted to have we wanted each of these samples, demo, starter kits to do things a little differently to show you that there's possibilities, there's different ways to approach things. In this case, we needed collision for the demo. Over the original demo, collision was very simple. So if you hit I think it's F1, isn't it?
Yeah,
that shows collision data.
Oh,
Control F1, I think.
Did I?
I
disabled it. I disabled it.
Good job.
Excellent.
But you can turn on the collision. You can turn on collision visibility, and you can see that basically it's taking the visual mesh and building a convex hull. And I just use a regular NuGet based convex hull generation program. It's not MonoGame based or anything. It's just a C# program that can generate convex hulls. So I feed the mesh triangle data into the convex hull in the pipeline or into the API, and it spits out a convex hull for me, or a bunch of convex hulls, and then I pack them into our model data, and then it gets read at load time so that I have pre-generated convex hull data. Then just a little bit of math in the game to do convex hull collision. So there he is.
Yeah.
So you can see there's a bounding box around it along with a convex hull inside of it. The character is currently just a cylinder, basically. Probably should be more of a capsule, but he's a cylinder at the moment. And, he's just sitting happily on that convex hull for that platform. It's not the most optimal way to do it. There's some, convex hull generation works, but it can be kind of fiddly, and you kind of want to adjust it per model. But for this example, I think it works perfectly fine. You could also do, like in the Ascent demo, which we'll talk about here in a moment, we've set it up where the artist can build a collision mesh for the visual model, and at model processing time, we extract the collision mesh and pack it in a format that's optimal for the runtime collision system. And you could do something like that here as well and specify collision hull in Blender, and then at runtime we could be using that. So yeah, I mean, that was a kind of a step towards making it play better, is having better collision, and it was just a couple days effort to pull that together.
Yeah, thanks for doing that, Tom.
No problem.
I mean, the original system, I was building this stuff at runtime, so we had a coarse collision box, and then I was building a more detailed collision box from the mesh at runtime using code that you can find on various XNA samples, but that wasn't very efficient, and it would. This is a much better solution. So let me just come out of that a minute. Yeah, so we got the pipeline project, which does all the mesh animation processing, and then generates the hulls and then sets all that up. This is very standard stuff. Yeah, and then it's just all that. This is all the content from Kenney. I mean, the one thing that I did actually find is that we have to use the GLB for the character, not the FXB, because of the way the animations are stored in the FXB. I still need to work on that, but using a GLB is fine. That works perfectly well in this particular case.
Can you explain what the difference is between a GLB and a FXB just quickly?
The GLB is like FXB is a 3D model format. It's quite old. GLB is quite new. It's like a more modern standardized format. You can do a lot more stuff with GLBs than you can with FBXs. You can put more data in them, but in this particular case, all we needed was mesh and animation data. The animation data was stored all together in the GLB file, but in the FXB file, it's scattered all over the place and has weird animation names. I think it's to do with a Blender export issue. So we'll still need to look at if we can support that, but GLBs work fine for the time being. And GLB is probably the way we want to go at some point, to be honest, because it's newer. So the main thing, I'm rather conscious of time, so the main thing I wanted to show was how we link this with Blender effectively. So I've got Blender open here, obviously, and we have, so this is the level that you've just seen in the game. It's all there. You can just select, cut, copy, and paste, and do everything that you want to do in Blender without any problems. So if I just shift duplicate that, for example, and then we'll move it to level 3. And we'll go and have a look at level 3. So this is the thing that I just moved, and that's I'm just going to move it around to get it somewhere where I can jump on it. Oop, nope, not there. That'll do. So basically, what you do is you grab your objects, you just position them wherever you want in the Blender scene. This is the goal sphere that I was telling you about. So what we do is, if there's objects that have specific behavior, we use custom properties in Blender. So you can add custom properties to your objects, and then we pick them up in the export process, and then the JSON loader is responsible for looking at those in the C# side. So this one has a flag that it's the goal. This one has a flag that it's a spawn point. The type of this particular platform is a falling platform, so it will pick up different behavior in the loader because of its type. This one is the moving platform, and as you can see, we've got some min-max setting custom properties that will define in which direction, what is the minimum and maximum it can move within a certain area, and we'll just lerp between those two.
Right.
So this will move not just up and down, but also in any direction you want. So if you set
Right.
X and Y, it will lerp between both of those, but it will do it in a straight line. It's very
Right.
basic. It'd be nice to have like a path, and we'll figure that out at some
Right.
point. But
I mean, technically, you have a path, right? It's just 2 points on a path.
yeah. But if we
You know?
we could probably actually just
Define
have
a whole
it so
path.
define a whole path in multiple points, and then export that somehow. So the
Right.
exporting system is literally this Python script. Now I've messed around with, yes, I've messed around
Wait,
with the
not a
messed
C#
around-
script?
no, you run Python in Blender. Sorry.
Yeah.
I've messed around with Blender for quite a few years, so I've been messing around with the Blender API. So this just loops through all the collections. If the collection starts with the name level, it says, right, okay, I'm going to export these. And then you're just basically querying the type. Is it a light? Is it an empty? If it's not, then it picks up like, this is where we get those special custom properties. So as you can see, so if the platform is a moving platform type, we'll grab that max move, we'll grab the min move and the speed, and then we'll write that data into JSON. So if I just run that script now, and then we'll go back to, no, I'll tell you what we'll do. We're not going to do that there. Nope. I don't want to have to go through all of it again because I'll just fall over. So we'll just start on level 3. We should see our platform, which I added.
Cool.
Which is great. And all of that is kind of just still behaves the way it should do. And it just takes care of, it's all taken care of by the script. So you could potentially give, your artist friend a copy of Blender and just let them build out levels, which is quite nice.
Who says MonoGame doesn't have a level or a 3D editor?
Yeah, so let's have a look at the very quickly before I hand over to Tom, because Tom's got some updates. So this is the C# code for actually importing the JSON file. So what we've done is we map different content types. So if we look at the content models, we've got things like falling platforms, grass platforms, moving platforms. You map those in here to the type of C# entity to want to use. So there's the moving platform and the falling platform code. And then we basically just load it. We pick out its type from the JSON file. I'll pull up the JSON file because that'll probably be quite helpful for people to see. So let's have a look at the falling platform we just added. There we go. So we have a name, a type, what it's an instance of, which is how we map. That's how we map to. Should be an instance of somewhere in here. It's how we map to this stuff. Yeah. So we just read all this information in, and then it generates the correct item type. So adding that moving platform was as simple as adding the FBX, adding the new type, which did stuff, and then registering it here. And then you can just add another platform. So we can keep expanding this now that we've got this framework. And I think that's about it, unless any of the team have got any questions.
One question did come in about when we're hoping to get this released, because I think we're still finalising it and going through. We'll probably announce more later on. But
yeah, I think we're going to open the repo to patrons like we did.
Take a drink.
Yes, I need a drink. We're going to open this up to Patreons like we did the Ascent demo for the time being. It shouldn't be more than about a month or so, and then we'll make it public. But we just want to get a bit more polish on it. There's a couple of little things that we want to fix. I know there's a couple of things on Tom's to-do list they want to fix, and I want to expand out like level 3 a bit more as well. But I mean, this time we're going to open it up to, I think we agreed it was going to be sprite batch level and above, wasn't it? Or was it?
Yeah, I think that's what we're talking about.
Yeah, sprite batch and above Patreon this time around, rather than the next tier up, which was user draw primitive. So I think if you're paying like $4 a month to Patreon, you'll get complete access to this. You'll have to let us know your.
To support MonoGame and to help us keep continuing things like this and getting more and more kits, because the more stable the funding is for MonoGame, the more we can do and the more we can show, and the more people can start making their own projects using the skills and the tools that the foundation team bring to the party.
Yeah, definitely.
Right. It's about giving new developers a starting point, right? Like everybody has to start somewhere. A lot of developers started, modding Minecraft or building stuff in Game Maker. Like you have to start somewhere. And these starter kits give you a good starting point, where it's like, hey, this is a good little platformer, but I have these ideas for gameplay that I'd like to do. And this gives you kind of a full kit, right? You get a simple level editor, a bunch of simple primitives. You get all the basics that you need, some lighting, some shadows, some audio, some music. You have everything in place. And you can start, iterating from there and taking that project somewhere else. That's the idea. And then we plan to repeat this with other demos.
Yeah, if I'm going to be honest, I've got game ideas that I've been wanting to do for years.
Right, exactly.
And that will use this.
Right, as a starting point, right.
Yeah, it's just as a starting point, because I've always wanted to do certain 3D games, and it's like, okay, but this little project gave me that push to actually start putting this together.
Right.
And like I said, the Square has asked FPS Kit Next. We're going to look at what other kits they've got.
Already discussed it.
We've already discussed it. He's got 2 more kits, so you'll have to wait and see which one gets done next.
Oh, right. Someone's already posted into the chat as well, saying he's got an FPS starter kit. Wonder what we could do with it.
Yeah. So, I mean, yeah, this was a fun project. I really enjoyed it. And thanks to Tom for helping out with some of the stuff the last month.
Yeah, no problem.
I was wondering the question to that, Dean, as well, is that out of what you've learned in converting Kenney's sample, so what kind of things can we see might be added back into MonoGame itself to ease other projects and doing it beyond the starter kit itself?
I mean, one of the major blockers was sorting out the mesh animation stuff. I personally would like to see. I don't know whether the rest of the team would want this, but I personally would like to see better model animation support, even if it's just skeletal animation only kind of stuff. We should have that built in rather than having to do like a separate pipeline. I mean, don't get me wrong, having your own pipeline to deal with your animations your way, or even your models, that's something you should absolutely be able to do. But just to help people get started, then I think little things like having a mesh animation would work quite well. The shadow stuff, not so much, because having done this, I think it's very personal to the project, unless you're writing an engine, which we're not. We're writing games. And I think that's the lesson I've learned from this is don't focus on writing an engine or architecting it the correct way. Just write your game. And
Right, exactly.
Tom told me that. He said it does it
Yeah,
because I was quite skeptical about this when I got to that first stage, and I said, "Oh, it's not very good." And you said, "Does it run?" Yes.
yeah. I mean,
That's
that's
good.
all that matters. I mean,
Yeah.
with our studio doing enough game ports, we've seen tons of people's code. The quality of the code doesn't matter. It doesn't matter if it has every feature. What matters is, I mean, there are games that ship on Unreal Engine that don't use half the features Unreal Engine has. Like, it's not necessary to have everything. It's necessary to have what you need for your game. And MonoGame's always been about, we're not providing an engine. We're providing a framework and an ecosystem of tools that you can use and different ideas of how you can approach your own games. And a lot of people start their games and this is really a classic way of starting games. Before there were game engines, which was a thing, you would start with, well, what are we building? Let's build what we need to build this game. And that's the approach here is you're trying to build what you need to build this game. But we're giving you a hand up by providing, third-party libraries, like the ecosystem of C# libraries that are out there. Like, again, like I was like, how do I solve collision? I need better collision here. It's like, well, convex holes is enough for this game. It's very simple. I don't want to integrate a full physics engine, so simple convex hole collision isn't too difficult. The math's pretty straightforward and it's well known and the performance is good. But I need convex holes. It's like, well, I don't want to go build a bunch of convex holes for these meshes. So how do I do that? And I just did a quick search and found, oh yeah, on NuGet I can find this convex hole generation C# tool. So I'll just plug that into the content pipeline and have it generate convex holes for my visual meshes as a starting point. And that, was a one afternoon decision, kind of got it working. And then the next day finished it up and cleaned it up. And we have good convex hole collision. So that's the process. And that's what we're showing with this is that you don't have to start from an engine that has every feature. You start with, just a bit of code and you start adding on elements that you need. And that's really all that you need to build a successful game. Towards the end, it becomes a difficulty of, balancing some of the decisions you made early on with, where you're at the end, right? Like you get code debt the more stuff that you add.
Yeah.
But, focusing on what's important to the game is important. Like the lighting here is very specialized because it's very specialized for this type of game. Like, I don't know if anybody's ever noticed, I dove in this a little bit looking at this demo, was like, if you look at the more modern Mario games, like Mario always has a shadow directly below him, even though the shadows in the environment point a different direction. That's to facilitate jumping, and you have to, you have to develop your system to work that way in order to get what you need. So it's things like that you have to think about, like, what do I need for this game versus, a generic engine that can do everything but doesn't necessarily fit your game. So those are the important parts when we were thinking about when we were working on this.
Yeah.